Hello, welcome to Notes 5.2, Standard Deviation. So now that we've collected the data in 5.1, right, with our different sampling and studies, now we're going to start to analyze the data. So one of the ways that we do that is with what we call the arithmetic mean. Most of us know that as the average. So to find the average, you're going to take the sum of all the data and divide it by the number of pieces of data. Now, for us, that's going to be often denoted with the Greek letter mu. So this little like curly fancy u means average, but we call it mu. So mu, the average, is found by adding up all the data and dividing by the number of pieces of data. So the sideways fancy looking M is a summation symbol. That means sum. So X is our data points and N is the number of data points. So X is data points, N is the number of data points. The sideways looking M is what we call a summation symbol. It means to add, a sum. So this is how you find the average in symbols, what I just boxed. But what you are actually doing is written out there in words. You're summing, you're adding up all your data and dividing by the number of pieces of data. You might also see, if you're looking down here, you see the symbol X bar, right, with an X and a bar over it. We just call it X bar. That's the same thing as mu. So mu and X bar mean the same thing. They mean the average. So you'll see both of those used throughout like notes and worksheets. So mu, X bar, same thing. Just different way to write it. So the concepts of variance and standard deviation, you might have heard of standard deviation, variance. They're probably a little unfamiliar to you. But basically, they're going to help us determine how spread out the data is. So here's an example of two students who took 10 quizzes at a psychology class at Clearwater State. So there are the scores, student 1, student 2. So standard deviation is how spread out the data is. So looking at the two students, student 1, student 2, look at their quiz scores. So the question is, which student do you think is going to have lower standard deviation? So that is going to be a student whose quiz scores are closer together. So pause the video and pick which student you think has the lower standard deviation. Pause the video now. So hopefully you just unpause the video and you wrote down hopefully student number 1. And why is that? Because the quiz scores for student 1 are less spread out. Right? They don't vary as much. So we're going to calculate the mean, variance, and standard deviation for student 1 and round to the nearest tenth. Remember, tenths place is 1 decimal. Right? Tenths, hundredths, thousandths. So tenths is 1 decimal. So first we're going to calculate the mean. So you're going to say the symbol mu or X bar. You'll see both of those. So what you're going to do is right now you should be adding up all the numbers for student 1. So we're adding up all 10 scores. And then we're going to divide by 10 because there are 10 scores. So if you add them all up, right, doing that right now, you should end up with 850. So the average score, right, the mean is 85. So you have your data points in this table already listed for you, X, right? You have X bar. You could also call that mu, right? So you could call mu and mu, right? So mu, right? X bar, mu, same way to write average. You'll see both symbols. So you just want to kind of understand they mean the same thing. So your average is 85. So I'm going to write 85s all the way down here. 85 all the way down. Okay, so now the next column, right, asks you to take x and minus x bar, or take x and minus mu. So we're going to subtract the two columns, the one on the left and the one on the right. We're going to subtract the two. So this would be 0. This would be negative 3, right? This would be 5. Then 4. Then negative 3. Then 5. Then negative 1. Then negative 4. Then 2. And then negative 5. And then the last column takes what we just subtracted and we're going to square it. So x minus x bar squared, or x minus mu squared. So we're going to now square those 10 numbers that we just got. So 0 squared is 0. Negative 3 squared is 9. 5 squared, 25. 16, 9, 25. 1, 16. 4, 25. Notice all 10 of those numbers should be positive numbers every time because you're squaring. So you should always, in that very last column, have positive numbers. Always positive. So we're going to find the variance. So in order to find the variance, we need to first add up our 10 numbers here in the last column. So we're going to add those 10 numbers up. So do that now. Right, on paper, grab a calculator, but if you add them up, right, you should get 130. So you add the 10 numbers up. So to find the variance, we'll use the symbol, which we call sigma. So a Greek symbol, right, it's like an O with like a hat, right? This is sigma. So the variance is sigma squared. So you do that, you take the total of that last column, which is 130, divided by how many pieces of data. So the variance is 13. So again, you take your last column, you add it up, which is 130. Divide by how many pieces of data, and that will give you your variance, sigma squared. The standard deviation is sigma. So we have sigma squared. To get the standard deviation, we need sigma. So we're going to square root, right, the sigma squared. That's how we're going to get our standard deviation. So it's going to be the square root of 13, which is about 3.6. So we find the variance by adding up the very last column, which is 130, divide by how many pieces of data, which was 10, right? So that's 13, and then to get the standard deviation, you take the square root of the variance. So the variance depends on the column, and the standard deviation, we will often have to have the variance to find that. Right, so let's move on to the next one. So now find the mean, variance, and standard deviation of student number 2. So again, remember x bar is the same thing as mu, so you could write mu's here as well, because you'll see both. So first we need mu, right, which is the average. So we need to add up all of our 10 numbers, so add those up and divide by 10. So pause the video, add those up, right, and then divide by 10. So now hopefully you added those numbers up, right? And if you did, you should have gotten 770 divided by 10. So mu is 77. So right here in this column, I'm going to write 77 all the way down. So now in the next column, I'm going to take x, so my data, and I'm going to subtract mu. So I'm going to subtract these two columns. Subtract. So negative 19, 15, negative 7, 8, 18, negative 32, negative 6, 22, negative 12, and 13. And then the last column, I'm going to take the numbers I just got, those 10 numbers in red, and now I'm going to square them. So I'm going to take these 10 numbers in that third column, and I'm going to square them to get the fourth column. So this is 361, 225, 49, 64, 324, 1024, 36, 484, 144, 169. And again, notice all 10 of those green numbers are positive. Those numbers should always be positive because you're squaring numbers. Any number you square will always be positive. So now to calculate the variance, which is sigma squared, you're going to add up the very last column and divide by the number of data points, so 10. So add up that last column, right? Add up all those numbers. So pause the video, add those numbers up, and then continue on. So now that you've added them up, you should have gotten hopefully 2,880. So divide that by 10. So our variance is 288. So we get the standard deviation. Sorry, variance is sigma squared. Standard deviation is sigma. So we're going to square root 288. And that comes out to about 17.0. Because remember, we're rounding to the nearest tenth. Okay. So one of the questions that we have to answer here is how many quiz scores for student 2 was within one standard deviation of the mean? So in symbols, right, you have the mean, which is mu, within one standard deviation. That could be above or below 1 sigma. That's what it's asking us, right? One standard deviation. Sigma is standard deviation. So within one standard deviation above or below the mean, how many quiz scores fall in that range? So the mean is 77. Our standard deviation was 17. So let's figure out our interval, where we're looking for. So up here, right, 77 plus 17 would be a quiz score of 94. 77 minus 17 would be a quiz score of 60. So how many quizzes fall in the range of 60 to 94? That's what it's asking me. That's within one standard deviation of the mean. So how many quiz scores are between 60 and 94? So count those. Right? So again, pause the video and count how many quiz scores are between 60 and 94. So hopefully you got numbers 65, 70, 71, 85, 90, and 92. So that means there are 6 quiz scores were within one standard deviation of the mean. One of the things you're going to see in this unit is you're going to have to make sure you justify your answer, and that's usually going to be within a sentence or two, right? So we got 6 quiz scores that were within one standard deviation of the mean. So these are the 6, and those are quiz scores within one standard deviation of a mean. Those are within the range of 60 to 94. All right, summarize what you discover when you compare the standard deviation of the two students. So the standard deviation for student number 1 was 3.6. The standard deviation for student number 2 was 17. So what do you notice about the two? Right? Student 2 definitely has a bigger number, 17 versus 3.6. So what does that mean? So student number 2, right, has a larger standard deviation. Well, why? Why do they have the larger standard deviation? Why is their number bigger than student 1? Because why? Standard deviation is how far the data is spread out. So that means if you have a larger standard deviation, your data is more spread out. So the scores were much more spread out. Spread out. All right, summarize what you discover when you compare the ranges of the two students' quiz scores. So range is the difference between the highest and lowest score. So for student 1, right, the highest score was a 90, the lowest score was an 80, so their range is 10. For student number 2, the highest score was a 99, the lowest score was a 54. So their range is, lowest score was a 45, which is a difference of 54. So student number 2 has a much bigger range, which hopefully should make sense because their data is more spread out, right? That they would have a bigger range than student 1 because their data is closer. So again, range is from the highest to the lowest. So this section of notes is about finding standard deviation, finding the mean. We had some Greek symbols, right? Mu, the U shape means sum, means your average. We had the sideways M, the summation symbol, right? That means sum. X bar and mu mean the same thing. They mean average. We had sigma, which we would use for standard deviation. Sigma squared is variance. We do have to create that table to find our variance. And then once we have our variance, we take the square root of that variance to get our standard deviation. So again, some terminology you're just going to have to get used to. Greek symbols, you're going to see them enough where they start to kind of come easy for you to understand. Range, again, how far the data is spread out from highest to lowest. So answer the essential question with your summary, right? And you'll be done with your notes. Have a great day.